Hey stats guys, let's go over how to get a stat plot in or a scatter plot into Excel or Google Sheets. So I'm going to click the little copy button and copy this to clipboard. Control C if you have a PC, Command C if you have a Mac. We'll copy that and then Control V, Command V, we'll paste it. Alright, once we have that, to make a scatter plot, we're just going to select column A where the X's are, hold down Shift, go to the right, select column B where the Y's are, go up here to insert and then tell it to insert a chart, and then by default it typically for 2 columns of data it typically will give you a scatter chart. Not always, but that's the most common thing when we have 2 columns of data like this. So if it doesn't give you that, you'll just need to, let me show you, you'll need to come over here to where it says scatter chart, click that and it'll have it in the suggested most likely, just because it's 2 columns of data. That's one of the most common things. But if you don't see it there for some reason, just come down until you see scatter. Alright, so there's my scatter plot. Alright, I'm going to shrink it down just so we can see. But you can obviously tell that that's option D there. It's the only one that has that bend, that downward bend to it at the end. So it's option D. And then the next question says, find the correlation coefficient. So I'm going to move this out of the way. Label this R. In Sheets and Excel both, the correlation command is equals. You start typing the word correlation, C-O-R-R, and there's C-O-R-R-E-L, correlation. Same thing for Excel. And when I click that, it wants to know where are your Y's, where are your X's. By default, it's like picking up that these are probably them, but it's got them kind of reversed. It's got X first, then Y. And the thing is, it doesn't really matter. I'm going to show you that if I do Y first like it says, comma, then X, and I can also, by the way, I can also just click the columns. So I could do B, comma, A, and it'll give me that for the value of R. But if I reverse it, I just want you to see again, this is the B's are the Y's, the A's are the X's, which is what it says. If I reverse it, equals C-O-R-R, correlation, and I do the X's first, A, comma, B, it gives me the same number. So the correlation is the measure of the linear relationship between X and Y, and it doesn't matter who's X and who's Y when we're just describing that number. Now it is important going forward into 10.2 who's X and who's Y, but for right now, for just correlation itself, the number can be found with either command, X first then Y, Y first then X. Alright, because that value is 0.816, it's asking us, is there sufficient evidence to support the claim of relationship? And that's when this table comes into handy. So if I click that, it's wanting us to use alpha equals 0.05. So we have 11 data points, and for 11 data points I can see at 0.05 correlation just needs to be above this number. So 0.602, and we're above that number. So we definitely have correlation with this many data points. We would have it at the 0.01 level. So we have to be above 0.735, and again we're at 0.816. So there is significant correlation in the sample to suggest that the population has correlation. So that's why that one's selected. There is sufficient evidence because this R value is above the R value below 0.05 at our sample size. So 11, we just have to clear that for 0.05, and we do. Because of that, there is sufficient evidence to support the claim that a linear correlation does exist. Alright, and then ask, well, what would we be missing if all we did was look at the correlation value and the significance level, you know, or the critical value? What would we be missing? And the answer is that obvious nonlinear pattern there. Yeah, a line does okay here because it does rise as we go right, but there is a clear nonlinear parabolic relationship between these two. So that's why the scatter plot reveals a distinct pattern that's not a straight line pattern is the correct answer there.